Good afternoon, everyone. My name is Eliza May Sirantana, group member of the Group 10. Before we discuss our topic, which is the food production and the environment, let me first introduce my co-members. First, we have Renz Nino D. Munding. Second, Santiago B. Nilias Jr. Third, Jean Ivo. And lastly, Zara and Laga. Our topic is all about food production and the environment. So first, what is food production? Food production is the process of growing, harvesting, and processing of food. The environment is the surrounding or conditions in which a person, animals, or plants lives or operates. Food desert. Food desert is an area that has limited access to affordable and nutritious food. In contrast, an area with greater access to supermarkets and vegetable shops with fresh foods may be called a food oasis. People living in these urban neighborhoods tend to rely on convenience stores and fast food restaurants that mainly offer high calorie, high processed food that can lead to higher risk of obesity, diabetes, and heart disease.
The three scientific principles of sustainability is the solar energy, chemical cycling, and biodiversity. The solar energy is a form of radiant energy derived from the sun, primarily in the form of electromagnetic radiation. The sun emits photons, which are particles of energy that travel through space. These photons carries various wavelengths, including visible light, ultraviolet radiation, and infrared radiation, harnessed through the use of solar panels or photovoltaic cells which contain semiconductor materials. Second is chemical cycling, also known as biogeochemical cycling, refers to the movement and transformation of chemical elements or compounds through various biotic and abiotic components of ecosystem. It involves the cycling of elements such as carbon, nitrogen, phosphorus, sulfur, and other between different reservoirs, including the atmosphere, hydrosphere, lithosphere, and biosphere, driven by various biological, physical, and chemical processes. Biodiversity refers to the variety of life forms, including animals, microorganisms, and their interactions with an ecosystem. Encompasses the diversity of species, genetic diversity within species, and the diversity of ecosystems and habitat on Earth. Biodiversity is measured at studied at different levels. Species diversity refers to the number of different species present in a particular area or ecosystem. Genetic diversity refers to the variety of genes within a species. Genetic diversity is essential for adaptation, resilience, and long-term survival of population. Ecosystem diversity refers to the variety of ecosystems and habitats found in a region or across the planet. Biodiversity plays fundamental role in maintaining the functioning and stability of ecosystem.
Hello everyone. In here, what is food security and why is it hard to attain? So, food security is like the security of food itself. And most of agriculture experts agree that one of the root causes of poverty, food security, known as insecurity, is poverty. So, why? Because di man ta kapalit og kuan, di man ta kapalit og food if we don't have money. Syempre, sa panahon karon nabay magpautang. No, 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 no. Wala. So, in here, people tend to eat scraps or just bread or something. So, dili siya secure ang ilang food itself. So, magkapasmo-pasmo sila. Second, one of the other reasons that prevent is that the political view. So kana di ayong kuan pili-pili unsa pa na diha political view man ang reason na dili ay natagas ka dili na ato so bali scarcity na kay tag food mo pay daghan ta pilian pa jud. That's why. And then one of the reasons is that kana pong corruption syempre corruption unsa may mahatag po nila og nahurot na po nila hakot ng money to buy that particular certain amount of money to buy for the people itself. For example, mahatag ang gobyerno o nga sakas ang lugar pero wala gihatag dito tuwa day sa ilahara. That's one of the reason why lots of people suffer from death because of hunger and food insecurity.
How is food produced? Most food comes from domesticated animals and plants, and their production occurs on farms or ranches. Some foods are caught or harvested from the wild, such as some fish, mushroom, and game. Production means growing plants with harvest or raising animals used for foods. For example, sa mga foods nga itong nakuhan karon. They provide us with food which come from both plants and animals. These include grains, pulse, spices, honey, nuts, cereal, mixed vegetables, fruit, eggs, meat, chicken, etc. The extent of life is completely dependent on plants and animals. It depends sa how the plants and animals nga atong ginakuhan para maka-produce the foods. Many people have
health problems from eating too much. Overnutrients occur when a food energy intake exceeds energy use and causes exercise body fat. Too many calories, too little exercise, or both can cause overnutrition. People who can underfeed and underweight, and those who are overfeed and overweight share similar health problems. Lower life expectancy, greater susceptibility to disease and illness, and lower productivity and life quality.
Industrialized crop production relies on high-input monocultures. The two major types of agriculture are industrialized agriculture and subsistence agriculture. Industrialized agriculture or high-input agriculture uses heavy equipment along with large amount of financial capital, fossil fuels, water, commercial inorganic fertilizers, and pesticides to produce single crops or monocultures. The major goal of industrialized agriculture is to steadily increase each crop's yield, the amount of food produced per unit of land. Industrialized agriculture is practiced on 25% of all cropland, mostly in more developed countries, and produces about 80% of the world's food. Plantation agriculture is a form of industrialized agriculture used primarily in tropical, less developed countries. It involves growing cash crops such as bananas, coffee, vegetables, soybeans, mostly to feed livestock. Organic agriculture in which crops are grown without the use of synthetic pesticides, synthetic inorganic fertilizers, and genetically engineered varieties, and animals must be raised on 100% organic feed without the use of antibiotics or growth hormones. What are the differences between industrialized and organic agriculture? Industrialized agriculture uses synthetic inorganic fertilizers and sewage sludge to supply plant nutrients. It makes use of synthetic chemical pesticides, uses conventional and genetically modified seeds, depends on non-renewable fossil fuels, mostly oil and natural gas, produces significant air and water pollution and greenhouse gases. It is also globally export-oriented, uses antibiotic genetics and growth hormones to produce meat and meat products. While organic agriculture emphasizes prevention of soil erosion and the use of organic fertilizers such as animal manure and compost, but no sewage sludge to apply plant nutrients. It employs crop rotation and biological pest control, uses no genetically modified seeds, reduces fossil fuel use, and increases use of renewable energy such as solar and wind power for generating electricity. Produces less air and water pollution and greenhouse gases. It is regionally and locally oriented. Uses no antibiotics or growth hormones to produce meat and meat products.
Hello again. So here we're going to report about look closer at industrialized crop production. So in here, farmers have two ways to produce more food. So in terms of that, they have two ways to produce more food in order to feed the people. So in here, farming more land or getting higher yields from existing croplands. So since 1950, so about 88% of the increase in global grain production has come from using high input industrial agriculture to increase crop yields. So it is happened during in the 1950s rather. So this process called the Green Revolution. So it involves in 3 steps. So the Green Revolution involves in 3 steps. And what are they? So the first one is to develop and plant monocultures. So develop and plant monocultures of selectively breed or genetically engineer varieties of grain crops such as rice, wheat, and corn. Second, produce yields by using large inputs of water, synthetic and organic fertilizers, and pesticides. Third, increase a number of crops grown per year on a plot of land through multiple cropping. So it happened in the way of producing a food. It was being noticed or being developed since 1950s, and then nag-upgrade. So mauna to dito na sila gasugot og pesticides, insecticides para dili kayo madaot ang mga mga crops, kasi dito naman magsugod ang manifestation sa crops kanon sa mga insects started with nauban gasugod sa end rot. There are certain types of pesticides and pests in certain crops, and pesticides help to decrease the. Tapos they also uses a technique on how to plant per year. So gadiha gasugod ang crop production.
Crossbreeding and genetic engineering produce new varieties of crops and livestock. For centuries, farmers and scientists have used crossbreeding through artificial selection to develop genetically improved varieties of crops and livestock animals, such as selective breeding in the first gene evolution yield amazing results. For example, ancient ears or corn were about the size of your little finger, while but tomatoes were the size of grapes. But some larger varieties use now selected breed. For example, sa mga naiuban sa mga layar jud ng crossbreeding kay dagko result nindot like dili sa pas nga mga wala pa kakuan kay mga crossbreeding.
Today, scientists are creating a second gene revolution by using genetic engineering to develop genetically modified strains of crops and livestock animals. Engineers use a process called gene splicing to alter an organism's genetic material through adding, deleting, or changing segments of its DNA. The goal of this process is to add desirable traits or to eliminate undesirable ones by enabling scientists to transfer genes between different species that would not normally interbreed in nature. The resulting organisms are called genetically modified organisms or GMOs.
Meat consumption has grown steadily. Meat and animal products such as egg and milk area sources of high-quality protein and represent the world's second major food producing system. Between 1961 and 2012, according to the FAO, production and meat and beef product, mostly beef, pork, poultry, mutton, milk, cheese, and eggs, increased more than toward, and the average consumption per person of meat and meat product more than double global meat consumption is likely to more than double again by 2050 as income rise and millions of people in rapidly developing countries move up the food chain and consume more meat and meat products every year. For example, meat consumption in China increased ninefold between 1978 and 2013. About half of the world's meat comes from livestock grazing and grass in and fenced rangeland and enclosed pastures. The other half of produced food and industrialized factor farm system. It involves raising large numbers of animals bred to gain weight quickly, mostly in grounded feedlots in or very grounded pens and aged in hodge building called concentrated animals feeding operation CAFOS. Ang pagkonsumo sa karne nagpadayon nga nitubo ang karne o mga produkto sa hayop sama sa mga itlog, gatas, inugdan sa taas na kalidad ang protina og nagrepresentar sa kalibutan. Ikaduha ang mayor na sistema sa paghimo sa pagkaon tali sa 1961 o 2012 sumala sa FAO. Production sa karne o karne ang mga produkto, kadaghanan karne sa baka, baboy, manok, boton, gatas, keso sa mga itlog, mitaas, labaw pa sa 2 ka pilo o ang kasagarang konsumo sa karne. O ang mga produkto sa karne kada tawo labaw pa sa double ang pagkonsumo sa karne sa tibuok kalibutan. Lagmit mo double pag-usap sa 20 samtang mataas ang kita o milyong-milyong mga tawo sa paspas nga nag-uswag ang mga nasod ipataas ang kanida sa pagkaon ug mukaon o kadaghang karne mga produkto sa karne kada tuig. Pananglitan ang konsumo sa karne sa China ni usbag og siyam kapilo tali sa 1978 o 2013. Mga katunga sa karne sa kalibutan naggikan sa kahayupan ni nilipsip sa balili sa walay koral. Mga kabukiran siguro o mga sipsibanan ang mga laing katunga kahimo pinaagi sa usa ka industrialisado sistema sa uma sa pagbrika. Naglaki kini sa pagtaas sa mga daghang kinahanglanon sa mga hayop, ipataas aron dali pagkadungan timbang kasagaran sa mga tawo, pinglats o sa mga ballpen o mga hawla ang puno kaayo.
What environmental problems arise from industrialized food production? Industrialized agriculture has allowed farmers to use less land to produce more food, and this has helped to protect biodiversity in many areas by reducing the destruction of forests and grasslands for farming. However, many analysts point out that industrialized agriculture has greater overall harmful environment impacts than any other human activity, and that these environmental effects may limit future food production. The industrialization of food production has been made possible by using fossil fuels, mostly oil and natural gas, to run farm machinery and fishing vessels, to pump irrigation water for crops, and to produce synthetic pesticides, mostly from petrochemicals produced when oil is refined, and synthetic inorganic fertilizers. Fossil fuels are also used to process food and transport it long distances within and between countries.
Soil is the foundation of life on land. Soil is a complex mixture of eroded rock, mineral nutrients, decaying organic matter, water, air, and billions of living organisms, most of them microscopic decomposers. Soil formation begins when bedrock is slowly broken down into fragments and particles by physical, chemical, and biological processes called weathering. As shows profile of different age soil on which all terrestrial life depends is one of the most important components of the Earth's natural capital. It supplies most of the nutrients needed for plant growth and purifies and stores water. Organisms living in the soil remove carbon dioxide from the atmosphere and store it as organic carbon compounds, thereby helping to control the Earth's climate as part of the carbon cycle. You might think of topsoil as something found only in farm fields, but it underlies all forests and grasslands as well as croplands.
Hello everyone, so I'm going to discuss about our topsoil erosion. Topsoil is a vital component of natural capital that causes and stores the water and nutrients that needed by plants. So it is a replaceable topsoil and is one of the earliest most important renewable resources because our food production largely depends on it. So topsoil nutrients are recycled endlessly as long as they are not removed faster than the natural processes replenish them. So they are renewable as long as they didn't remove faster than the natural processes that replenish them. So thus the topsoil renewable is one of the Earth's most important ecosystem service, especially in agriculture. Why? Because if too much soil erosion lead to less productivity and agriculture. So it has a good side effects and also at the same time a bad side effects if it's being too much.
Soil erosion. Soil erosion, the movement of soil components, especially surface, litter, and topsoil, from one place to another by the actions of wind and water. Some topsoil erosion is natural, but such of it is caused by human activities. Soil pollution. Soil pollution is also a problem in parts of the world. Some of the chemicals emitted into the atmosphere by industrial and power plants and by motor vehicles can pollute soil and water used to irrigate soil. Pesticides can also contaminate the soil.
Throughout and human activities are degrading drylands, a major threat to food security in some of the world's water-short drylands, which are home for some 2 billion people, is desertification, the process in which the productive potential of topsoil falls by 10% or more because of the combination of prolonged drought and human activities that expose topsoil to erosion. Desertification can be moderate with a 10 to 25% drops in productivity. Severe, which a drop of 25 to 50%, or very severe, which a drop of more than 50%, usually resulting in large gullies and sad downs. See only in extreme causes. Thus, desertification led to what we call desert over thousands of years. The earth desert have expanded and constructed primarily because of climate change. However, human use use of the land, especially for agricultural purposes, has increased. Desertification in some parts of the world, mostly because of deforestation, excessive plowing, and overgrazing that leaves the topsoil bare and unprotected against erosion by flowing water and wind. In major threats to food security, some of the world's water-short drylands, which are home for some 2 billion people, called desertification, the process in which in the productive potential of topsoil falls by 10% or more causes of a combination of prolonged drought and human activities that expose topsoil to erosion. Desertification can be moderate with a 10% to 25 drop in productivity and with a drop of 25 to 50% or drop or more than 50%. Some of the factors responsible for land degradation are the loss of vegetation occurring due to deforestation, improper crop rotation, instruction of groundwater in competing uses of land for forestry, agriculture, pasture, human settlement of industries. Desertification reduces agricultural output, contributes to drought, and increases of human voluntary climate.
Agriculture contributes to air pollution and climate change. Agricultural activities, including the clearing and burning of forests to raise crops of livestock, create a great deal of air pollution. They also account for more than a quarter of all human generated emissions of carbon dioxide or CO2, which is helping to warm the atmosphere and lead to climate change that is projected to play an important role in making some areas unsuitable for growing crops during this century. A related problem is the increasing loss of agrobiodiversity, the genetic variety of animal and plant species used on farms to produce food. Scientists estimate that since 1900s, we have lost 75% of the genetic diversity of agricultural crops that existed then. For example, India once planted 30,000 varieties of rice. Now, more than 75% of its rice production comes from only 10 varieties, and soon, almost all of its production might come from just one or two varieties. In the United States of America, about 97% of the food plant varieties available to farmers in the 1940 no longer exist. Except perhaps in small amounts in seed banks and in the backyards of a few gardeners. Industrialized meat production has harmful environmental effects. Proponents of industrialized meat production point out that it has increased meat supplies, reduced overgrazing, and kept food prices down. Analysts also point out that meat production by industrialized agriculture is artificially cheap because most of its harmful environmental and health costs are not included in the market prices of meat and meat products. A violation of full cost pricing principle of sustainability. Industrialized meat production uses large amounts of energy, mostly from oil, which help to make it one of the chief sources of air and water pollution and greenhouse gas emissions. The Environmental Working Group has estimated that production of meat and meat products generates 10 to 20 times more greenhouse gases per unit of weight than does production of common vegetables and grains.
Aquaculture can harm aquatic ecosystems. One major environmental problem associated with aquaculture is that about a third of the wild fish caught from the oceans are used to make the fish meal and fish oil that are fed to farm fish. This is contributing to the depletion of many populations of wild fish that are crucial to marine food webs, a serious threat to marine biodiversity and ecosystems. System services. Another problem is that some fish meal and fish oil feed to farm raised fish is contaminated with long lived toxins such as PCBs and dioxins that are picked up from the ocean floor. Aquaculture producers contain to that the concentration of these chemicals are not high enough to threaten human health, but some scientists disagree. Fish farms, especially those that raise carnivore fish such as salmon and tuna, also produce large amount of wastes including pesticides and antibiotics used on fish farms. Yet another problem is that farm fish can escape their pens and mix with wild fish possibly disrupting the gene pools of wild populations.
Scientific process provides several benefits. Six of this is use of scientific pesticide is advantage and disadvantage. Proponents within that the benefits pesticide overweight and harmful effects. They point to the following benefits. One is they have saved human lives. Pesticide can prolong to live crops and prevent post-harvest losses. Currently, about 925 million people around the world are in 7 of us are going hungry. To reduce hunger, we need to increase food productivity. Pesticide help farmers to do that. For example, is kailangan natong masolve ang mga ginagawa natin makuha ng mga pesticide to avoid kanang magka-lower ang atong productivity sa foods para maiwasan ang kagutom. Number 2, they can increase food supplies by reducing food losses due to pests. They can help farmers to increase their profits. Official or pesticide companies estimate that under certain conditions or pesticide can lead to an increased crop yield worth as much as $4. They work fast. Pesticide control most pests quickly and have long shelf life and are shipped by unapplied. 5 is when used properly, the health risks of some pesticides are very low relative to their benefits according to some scientific studies. 6 is Newer pesticides are safer to use and more effective than many older later used being made of chemicals derived originally for plants. Were generally to use and less damaging to the environment that are many the older pesticide genetic engineering is also being used to develop resistant crops, training and genetically altered crops that produce biopesticide.
Pesticides have several drawbacks, as well as some organic pesticides are broad spectrum and many harms beneficial insects like pollinators, predators, and parasitoids. This can lead to secondary explosion of another pest. Number 1. To accelerate the development of genetic resistance to pesticide in pest organism. Genetic and intensive application of insecticides are responsible from the rapid development of resistance in many insect and mites. Selection by an insecticide allows some insects with resistant genes to survive and pass the resistance trait on the turn of feeding. Subsequent uses of the pesticide increase the proportion of less susceptible individuals in the population. Through this process of selection, one population gradually develops resistance to the pesticide. Worldwide, more than 50 species of insects, mites, and spiders have developed some level of pesticide resistance. Number 2, that can put farmers on the financial treadmills. Pesticide treatments is a condition where farmers apply pesticide to the extent that the pests become resistant to the chemicals. Farmers continue using chemicals without the sources of eliminating the pest. The main concern of the farmers is that the chemicals are harmful to humans and others organisms in the ecosystem. The chemical destroy the food chain as they contribute to the death of some organisms. Number 3. Some insecticides kill natural predators and parasites that helps to control the pest populations. Carbonates, organophosphates, and pyrethroids kills natural enemies that are present at the time of spraying, and 4 days or weeks afterwards. Their residues kill predators and parasites that migrate in after spraying. Natural enemies are organisms that kills, decrease the productive potential of or otherwise reduce the numbers of another organism. Natural enemies that limit pests and key component of integrated pest management programs. The important natural enemies of insect and mite pests include predators, parasitoids, and pathogens. 4. Pesticides are usually applied inefficiently and often pollute an environment. Pesticides may move with runoff as compounds dissolve in the water or attach the soil. Pesticides, particular runoff from areas ridden with pesticide can be pollute stream, ponds, lakes, and wells. Pesticide residues in surface water can harm plants and animals and contaminate groundwater. some pesticides harm wildlife. Pesticides and rodenticides are very useful for controlling mice and rat population, termites and weeds, but can pose significant risks to wild animals like hawk, owl, quarry, shark, deer, coyotes, birds, mountain lions, and bobcats can be killed by pesticides even though they are not they are not the target. Some pesticides threaten human health, affect the nervous system, others may irritate the skin or eyes. Some pesticides may be carcinogens, others may affect the hormone endocrine system in the body. There are alternatives to synthetic pesticides. Many scientists urge to us greatly increase the use of biological, ecological, and other alternative methods for controlling pests and disease that affect crops and human health. Here are some of these alternatives. We have full the pest. A variety of cultivation practices can be used to fake out pests. Examples include rotating the types of crops planting in the field each year and adjusting planting types of that mirror insect. Pest eaters starve or get eaten by their natural predator. For example, cutworms may be the key pest on high visibility athletic fields but not on adjacent land areas where the tropical level of cutworm damage is very deliverable. Provide homes for pest enemies. Farmers can increase the use of polyculture with uses plant diversity to reduce losses the pest by providing habitats for the predators of fish species. Important natural enemies of insect and mite pests include predators, parasitoids, and pathogens. Reduce the uses of synthetic herbicides. The control weeds. Organic farmers control weeds by methods such as crop rotation, mechanical cultivation, hand weeding, and the use of cover crops and mulches. Try using non-chemical management method on your lawn and garden, such as introducing beneficial insect and vine native plants, or use physical method including hand weeding, mulching, and setting crops to reduce chemical use outdoors.
Integrated pest management is a component of more sustainable agriculture. Integrated pest management, or IPM, is an effective and environmentally sensitive approach to pest management that relies on a combination of common sense practices. IPM programs use current comprehensive information of the life cycles of pests and their interaction with the environment. The overall aim of IPM is to reduce crop damage to an economically tolerable level. Each year, crops are rotated in an effort to disrupt pest infestations. When farmers detect an economically damaging level of pests in any yield, they first use biological methods or natural predators, parasites, and disease organisms, and cultivation control such as altering plants, time, and using large machines to vacuum up harmful bugs. They apply small amounts of synthetic insecticides, preferably biopesticides, only when insects or weed population reach a threshold where the potential cost of pest damage to crop outweighs the cost of applying the pesticides.
How can we produce food more sustainably? We can produce food more sustainably by using resources more efficiently, sharply, decreasing the harmful environmental effects of industrialized food production, and eliminating government subsidies that promote such harmful impacts. Many farmers are reducing soil erosion. Land used for food production must have fertile topsoil, which takes hundreds of years to form. Thus, sharply reducing topsoil erosion is the single most important component of more sustainable agriculture and one of the most important ways to increase our beneficial environmental impact. Soil conservation involves using a variety of methods to reduce topsoil erosion and restore soil fertility, mostly by keeping the land covered with vegetation. For example, terracing involves converting steeply sloped land into a series of broad, nearly level terraces that run across the land contours. Each terrace retains water for crops and reduces topsoil erosion by controlling runoff. Another way to greatly reduce topsoil erosion is to eliminate or minimize the plowing and tilling of topsoil and to leave crop residues on the ground. Such conservation tillage farming uses special tillers and planting machines that inject seeds and fertilizer directly through crop residues into minimally disturbed topsoil. Weeds are controlled with herbicides. This type of farming increases crop yields and greatly reduces soil erosion and water pollution from sediment and fertilizer runoff. Still, another way to conserve the earth topsoil is to retire the estimated one-tenth of the world's highly erodible cropland. The goal would be identified erosion hotspots, withdraw these areas from cultivation and plant them with grasses or trees. At least their topsoil has been renewed.